Congruent and similar figures. Everyone tell your neighbor what congruent means.
Equal.
I hear the same. I hear equal. What does similar mean? Sort of alike. Same shape, but maybe not the same size. It's like the mini-me, right? The mini version. All right. So, yeah. Okay. Good. Good reference there. All right. So, congruent circles. You went through the notes. Congruent circles have what? Congruent radii. And radii is R-A-D-I-I. I think it's R-A-D-I-I. Think it's R-A-D-I-I. Think it. Sorry. Bad joke. Okay. Congruent polygons have? Uh-oh. Cameron. Corresponding parts are the same. There's too many words. You're right, though. Yeah. Oh, congruent, corresponding parts. All right. Which is corresponding parts are the same. Yes. Okay. But they didn't fit in the blocks. Yeah. All right. Congruent corresponding parts. What's corresponding mean? Like my right arm corresponds to your right arm. I know. My left arm corresponds to your left arm. My elbow corresponds to your elbow. My knee bone corresponds to your. Okay. We could do like the. Oh, we won't go. All right. Yes, heads. Yeah, who's saying it? Nice. Yeah. All right. And eyes and ears and mouth and head and shoulder, knees and toes. Okay. Define similar. Well, we talked a little about it. Similar means the same shape, but possibly a different size. Okay? Same shape, but definitely could be a different size. So, for instance, I could have a right triangle that looks like that, and another right triangle that's a mini-me version that looks like this. And those figures could be similar. Now, that would mean that they are not necessarily, they're not the same size, but they are the same shape. Okay? So if I put measurements on here to show that they are similar, I'd want to have sides, corresponding sides would have to have the same similarity ratio. So for instance, if this side length was, say, 5, actually let's make this one 10. That one is 5. That has a similarity ratio of, ratio just means fraction, in comparison. If I'm comparing those two, it would be 10 to 5. That would be the similarity ratio. Now, in order for this side right here to show that these figures are similar, if I called this side 6, then this one would have to be, the corresponding would have to be 3. So if I called that x, it would actually, I could set up a proportion to find that if I didn't know. Okay? I noticed my big triangle's on top, so I put the 6 there, and the small triangle's on the bottom, so I put the x there. And how do I solve a proportion? Well, I could cross multiply. Most of you wouldn't do this because you just know the answer on this problem, but as we do in math, the problems always don't stay that easy. So x would be 3. Okay. The similarity ratio is, what's the similarity ratio? Everyone on your fingers, what's the similarity ratio? See if we got the, some of you have some messed up looking fingers, dude. Oh, there we go. Similarity ratio is 2. Because when we compare a side, 10 is to 5, right? That gives us a ratio of 2. 6 is to 3. 6 is to 3. That gives us a ratio of 2. Similarity ratio is 2. Okay. Or 2 to 1, if you're thinking in fraction form. Okay. Yes?
Wouldn't it be half because you're downsizing it?
That would be if you're, yeah, that's another way of thinking. It could actually be 1/2 or 2, but if you're comparing this figure to that figure, it's 2 to 1. If you're comparing this figure to that figure, it could be 1/2. So your ratio, depending upon how you compare them, could be a reciprocal. Yeah. Okay. Now what do you think you got us so far? All right. Tell your neighbor what you just learned, what you just went through here. Go. Hey, everyone has their worksheet. Everyone has their worksheet now. What we're going to do is we're going to work through the problems up here, 4, 6, 7, 8, 15, and 16 as a class on the example side. Okay? So taking a look at your worksheet, your assignment is both sides all today, just so you're aware. Okay? I'd like to go through some of these together. So taking a look at this example number 1, I want you to read the instructions and everyone give your neighbor a thumbs up or thumbs down on whether or not you get what they're asking there. Okay? Now that you've looked at example 1, the temptation is to do example 1, which is talking about example 2, and then you don't know what's going on in example 2, and you're like, hey, hold on, can you hold me on example 2? And I just did the problem with the class, and I go, hey, I just did that, and you're like, oh, I didn't know. Okay? Yeah, that's because you're not paying attention. So pay attention. We're now on number 4. Everyone read through number 4. All right. Tell your neighbor what you're going to do on number 4.
I'm going to have like one angle that's like congruent.
Anyone want to tell me how we're going to complete number 4? Carson. Okay, yeah, you get the shapes so they look like they're in the same position. So if you wanted, you could flip these shapes. The other thing we haven't talked about yet this year, not enough, is that when they give you a triangle, they generally, the order in which they give it, if they're saying these are congruent, then F is congruent to M, first position to first position. G is congruent to P, second position to second position. And we're talking about angles. H is congruent to Q, third position to third. So when I look at F and M should be the same. G and P should be the same angle. H and Q should be the same, which would mean this line, FG, should be congruent to that line, MP. Everyone see that? Also means that GH should be congruent to, tell your neighbor. Good, PQ. So GH to PQ. You should be able to look at how they write it here and then verify by looking at the picture. You should be able to tell by that though. Yeah, go ahead, Bethany.
Write it line FG is congruent to line MP.
Yeah, you would write it line FG is congruent to line MP. Yeah, you'd want to go MP versus PM because let's start trying to match up corresponding pieces. Okay, so I'm going to start getting more picky about that. So far this year I've allowed you to go from just call FG and then PM, that's okay. But now that we're talking about congruent figures, I want F to G, M to P. Okay, how many pieces of these triangles are congruent? How many say 1, 2, 3, 4, 5? Do I hear 6? Do I hear 7? 7? Anyone 7? Okay, so 6 is the greatest. How many people can find 6 parts of this triangle congruent to 6 parts of this triangle? All right, go ahead and tell your neighbor what those parts are. There are 6. Hey, pretty good. So I'm going to go with angle F to angle M. So that's how we would write it out. Angle F is congruent to angle M. And notice I can just use the angle, the one letter, because there's only one angle coming off those. Okay, I can say angle G to angle what? P. I can say angle H to angle Q. Good. You guys, one bad habit I get into is my angle mark starts looking like a less than sign sometimes. So don't get into that bad habit. In fact, I've had the math department that the teachers I work with, they make fun of me sometimes. It's not choosing love, is what I think. And it makes me sad. FG is congruent to MP, military police. Okay. GH is congruent to PQ. Mind your P's and Q's. There they are. And F what? FH. Yeah. FH, yes. So exciting. Is congruent to MQ. Good. All right. Notice I didn't look at the picture much at all. I just went based upon their statement. Okay. All right. Any questions there? Pretty neato. All right. Hey, let's move on to number 6. I know that you want to keep working forever because it's amazing fun. We're going to do 6, 7, and 8 together. Art is, what in the world does this mean? What's that thing? Art has got a cool looking hairdo. Okay. Art is similar. This is the sign for similar. It's the little sign that's above the congruent symbol. Like if you look at congruent, it's a little sign above the equal part on the congruent symbol. Okay? It's the wavy hairdo. Okay? Art is similar to bus. Okay? So in other words, this art is similar to this bus. Write the similarity ratio, find angle U, and find SB. Okay, so we're going to add little things to our notes here and there. That's one thing that should have went into your notes. That's what similar means. If you ask me on your quiz or your test, you're like, hey, what's this little thing mean? Is that like a mess up on the copy machine? And you're like, no, dude, that's a mathematical symbol. I can't tell you what it means, though. It's top secret on a quiz. Okay, so I want you to work with your groupies. Try to write out that similarity ratio. Figure out what you think U is and SB is. Pause just for a minute.
Well, I have.
Let's make sure that we're clear on similarity ratio here. So we can compare 12 to 10, right? These are the two corresponding sides that have a measurement. So 12 is to 10. So we're going to go left to right unless they're right under each other. Then we'll compare top to bottom. But 12 is to 10 and we can reduce that to, yeah, 1.2 or ratio. Let's leave it in a fraction. What goes into 12 and 10? 2. How many 2's go into 12? 6. How many 2's go into 10? 5. So our ratio, our similarity ratio is 6/5. If you left it as 12/10, I'd prefer you reduce. Okay? Measure of angle U. One thing we haven't talked about similar figures, the sides are different length, but angles stay the same. Similar figures have congruent angles. So it might be another piece to add to your notes. Similar figures have congruent angles. You guys catching that? You guys catching that? Similar figures have congruent angles? You guys doing SB? All right. Make sure we have that right. Angles won't change. So angle U is corresponding to R, they're the same. How about SB? Well, if we know A is to R, or A to R is to BU as AT is to SB. So if we know that 6 is to 5, that's our similarity ratio. So we get here. On the top, we're dealing with our big triangle. So as 18 is to, we called this X. You could either say 6 times what's 18? 3. So 5 times 3 is 15. That's one way to do it. Or you could cross multiply and divide. Solve it a proportion. Either way, you get X equals the big 1/5. Yeah?
So does it make a difference if the 12 and the 18 are across from each other or on top of each other?
No, it wouldn't. So if you wanted to write it as 12 over 18 equals 10 over x, that would be fine as well.
Yeah, that's what I got,
Yeah.
but I didn't get the right ratio.
So you should have 12x equals 180.
Yeah.
Right, cross multiply. I would hesitate doing that because you don't have an actual similarity ratio you're dealing with there. But when you divide, 12 goes in. Sure, it doesn't give you 15? Yeah.
Oh, no.
Yep. So the ratio could be 6 over 5 or 5 over 6. But what I'm saying, so that we stay consistent as a class, I'd like you to read from left to right. So this one to that one. Or if they're straight above each other, which I don't know if we have any like that on here. I think they're all left to right. But if like this one was below this one, I'd prefer you go top to bottom. Okay? Read it like a book, in other words. Okay. Guys, I really had 2 more problems with us, but I don't want to drag our class through them. So I want you to look at 15 and 16, see if you understand them. If you have questions on, I'll work through them with you. Otherwise, we're going to call it good. So take a look at them. I'll be walking around. Questions on number 16. First, most of you have done fine, just from what I saw, setting up your ratio. You say 5 is to 7. There's your similarity ratio. This side is to that side as this side, which is what you're trying to find, is to that side. So x is to 8. Okay, now pause for a minute. The danger with me just giving you your assignment and saying, okay, here it is that when I start talking, I don't get people listening. So that means you need to pause and participate. It makes the discussion go faster, plus it makes it more interesting, and you don't miss important stuff, the minor mistakes you'll make. You cross multiply, you get 7x equals 40. And then you get, 7 doesn't go into 40, so x equals? What does it equal? Everyone, really loud. It should be 47s. We're not going with a decimal. Why? Because it doesn't terminate. Okay? Unless it says round to the nearest tenth or something, then you can terminate, or you can round it. Here, it doesn't say that, so leave it as a fraction, please. Okay? Any questions on that? Logan?
Then for number 12 and 11 on the...
Well, that's the next piece here that I actually had a question on. It wasn't what I was going to go through, but this, how many of you know the Pythagorean theorem? Okay, the Pythagorean theorem with right triangles, remember, you have a theorem that helps you out. It's a squared plus b squared equals c squared. So if I have a right triangle and I know it's 2 legs, okay, that we can call either one of them A. Call that one A. I'll call that one B. So a squared, that means 9, plus b squared, which is 4 squared or 16, equals c squared. This one's c. So 25 equals c squared, which means c has to be square root of 25 or 5. That means this length is 5, and that's important because they ask you for this length right here. And you don't have a ratio. You don't have any way of knowing until you find that side. Okay? Unless you somehow know trig already, which that would be nice. Okay? Logan, your question is, do you have to round or something on GF?
Yeah, do you want us to round or do you want us to leave it as a decimal? Or do you want
I'd prefer you leave it as a fraction.
fraction?
Okay? All right, unless it terminates, right? So what's the fraction?
I just got a decimal, not a fraction.
Okay. Well, what 2 numbers did you divide to find the decimal?
4, or...
Like, what did you put in your calculator?
Oh, it's did 3 times 6 and then divided it by 4.
3 times 6 divided by 4 is 18/4, which is 9 halves, right? And 9 halves is, you could terminate that one because that's 4.5 4.5. Okay, so the common question I get from students that use calculators, how many have used a calculator for as long as you can remember? Okay, you have grown up with calculators. When you go, hey, this is what my calculator gave me, 4.5. How do I make that into a fraction? Where's the button? Hey, McCoy, where's the button? In this calculator, I don't know the button. Where's the button? Here, I have a new calculator. I don't know where the button is. The button that changes fraction to decimal. Okay, well, first, usually to get a decimal, you had to put a fraction into your calculator. That's the fraction. 9 divided by 2. Now, in Logan's case, he put 3 times 6 divided by 4. Well, 3 times 6 is 18 divided by 4. That's the fraction, which reduces to 9/2. That's the fraction, which terminates to 4.5. So you're okay if you wanted to. Yes?
And then also for 11, when I put it in, you got square root of 56.25. And when I did the square root of it, it wasn't an unscrewed numbers, it was just plain out 7 plus 5. Would that be okay?
7.5 is fine. Yep, as long as it terminates. Grace? That or that? Doesn't matter. Hey, guys, I'm fine with decimals as long as they terminate. Everyone understand what terminate means? It ends. Like, when I put 1/3 in my calculator, 1 divided by 3, it gives me 0.3333333333333. Like, look, it end. Well, that's because your display doesn't have any further to go. Okay? Or you put 2 divided by 3, you get 0.666666667. Okay, because your calculator is rounded. It has not ended. It ends when you get like 4.5 and there's nothing else. And there's room for more, but there's nothing else. That's a terminating decimal. And that's okay. You can put a terminating decimal. Just can't have a one that goes on and you've rounded. You cut pieces off. You don't want that. So either one is fine, Grace. Yep. Yeah.
So on 17 and 18, I'm trying to figure out the proportion. It ends up with a decimal or a mixed fraction.
So right there.
Yeah.
So you get
'Cause
3x
8 divided by 3 doesn't.
equals 8. And so x equals 8/3. That is your answer.
But would you be able to put 8/3 over 2?
That's it would actually.
And it goes back in?
Well, if you're checking it, but for now, that's what I want you to put. Yeah, I'd like you to report that. If we were to use it here, we'd actually manipulate it a bit. I don't want you rounding it. 8/3 is going to round to 2.66666666667. Okay? We don't want to do that. Good questions. Any others? Those are the little things that start costing you points later because you've made rounding errors, and that's not good. Chapter 6, you make rounding errors, your answers are like 2 or 3 units off. Sometimes 5 or 10 units off. That's not good. Okay, good job. Keep working there.